There it is, sorry. All right. Cool, so we'll just give it maybe another minute, still a few people trickling into the waiting room. But we are excited to have everyone. Should be a cool 3-session workshop, a lot to learn. Hope we're excited. Actually just got a short presentation from Trang the other day in the cadCAD community call on the RAI protocol. He's doing some work on it. So we've got some potential experts already in here.
No, we're not saying I'm expert. Totally beginner.
Well, you sounded like you knew what you were talking about, so we'll give you credit.
Thanks, Peter. Some new faces as well.
Yeah.
Hello, Walter, Shiwei, Robert, Mohammed, Jon. Cool. Barnaby, hello again. Great to have you.
Hello, Angela. Thank you.
Yeah, thanks for joining, everyone. All right. Yeah, a couple of hellos in the chat. Cool. Cool. Well, we've got about 4 minutes in, so I'll get started just so we can make sure to get through the whole program, and we'll keep an eye on the waiting room in the meantime. But all right, I'm going to minimize everyone on my screen so I can see what I'm presenting, but feel free to, yeah, still be looking around, say hi to everyone, wave, do whatever you want in the background. Cool. All right, let's get started. So I just want to say welcome to everyone. Thanks for joining the RAI workshops, Modeling the Money God, partnership between Token Engineering Academy, Reflexer Labs and BlockScience. And we're going to introduce everyone to the cadCAD digital twin over the next 3 sessions. So just a quick update on the agenda today. We'll do introductions and a program intro. So let everyone know what they're getting into the next few weeks. And then we'll get into the good stuff, intro to the RAI protocol, the RAI digital twin, how to use it. And then we even have some homework for all of you, so you can get your hands dirty. So first, we'll just do a hello from the organizers. So I'll start, it'll be really quick. So my name's Peter. I'm working with the Token Engineering Academy, helping to facilitate research programs and workshops like this, and have been with the TE Academy for about 3-4 months-ish, and just finished up my first research program. So I'm really excited to be starting number 2 here. And I'll pass it to Angela to say hi.
Yeah, hello everyone. I'm Angela, founder of TE Academy. I'm a listener here, but I'm super excited that we are able to host this program with Reflexer and BlockScience. I know this has been a great project. I mean, RAI is on the list of most interesting mechanisms for stablecoins for many projects. And this is why we are super happy to run these workshops. And yeah, excited to see what you guys in the program are able to make of it, and hopefully we create a lot of value together for this group and also for the overall token engineering community. I hand over to Stefan.
Thank you. Hi, everyone. I will also only listen today, but I'm super excited to have this series of workshops because I really want people to learn more about RAI, and especially the geeky part of RAI, not just like marketing. And for this, we have Guillaume with us today. He's part of the Reflexer team together with me, and he made a nice presentation, give an overview about RAI, what it is, and in general, how it works.
Great. And Guillaume, do you want to say hi?
Yep. Hi, everyone. Stefan already said everything you should know about me. So yeah, I'm developer at Reflexer since the early days, and I will make the overview presentation of the RAI system.
Nice. And Danilo, last but not least.
Yeah, so hi everyone, I'm Danilo from BlockScience. I'm I'm a research engineer there, and I was one of the leading people in developing the high digital twin. And also I'm a climate physicist by formation, so you are going to see a lot of analogies with climate projections and so on. And yeah, happy to meet you, all you guys. So yeah, I'll pass the floor.
Sweet. Okay. I think that's it. And we will continue to the program introduction. So just so everyone knows what they're getting into, quick reminder of the goal of the program. So by the end here, we are hoping you will be able to run, analyze, and modify the RAI cadCAD digital twin. So a lot of work went into it, and we're really excited to be taught in great detail from Danilo on how it works and how we can use it for our own use cases. And just a few resources, even though it's just a 3-session workshop, there's a lot of content and a lot of opportunity still to collaborate with other folks in the research group. So one thing we've done is set up a one-stop shop document. This is something we use in all of our research programs, and I will share the link right now as a great way to organize all the documents. Oops. There we go. Yeah, great way to organize all the documents. So be sure to save that, bookmark it. We're going to be adding content to it over the next few weeks as well. And the last thing I'll mention is the Discord channel. We also set one of these up in the token engineering Discord as a space for everyone all the participants to meet and ask questions and have discussions even outside of this. As I think it was Stefan mentioned, we are going into some technical details, and we really want to be able to engage with all of you who are going to be doing the homework assignments or searching your way through this content. So we wanted to make sure there was a space for that to happen. So we do have a Discord channel, and you'll find it right in the co-community section of the token engineering Discord, just in case that link doesn't send you directly there. There's a screenshot here. And with that said, since we do hope that everyone takes the opportunity to get to know each other a little bit, but there's a few too many of us to do individual intros over Zoom time-wise, we just wanted to give a few minutes for everyone to post a quick hello in Discord. So I'll go in and send mine as well, and would just be great to get your name or Discord handle, quick background, and why you're here. So feel free to click that Discord link I sent, find your way over there and give us a background, but we'll just give you a few minutes for that. I'll be in there as well. I was lucky I got to prep. And yeah, Doga, if you're on mobile or if anyone's unable to type at the moment, that's totally fine. The channel will be there for for the duration of the program, at least. So just jump in at any time. You can scroll up, see who else is around, send your intro later. That's all right too. All right. Hello, John. Hello, Serious Business. It's an awesome tag. right, Danilo. Give another 30 seconds maybe. And if you haven't quite finished by the end of it too, just save your draft and jump in after the program. All right, cool. So I think a few more people are still typing, but that is not a problem. We're just gonna get back into the introduction so we can get moving. So feel free to hit send at any point over the next hour or whatever, even the weeks to come. So I'm excited to get to know your fellow researchers and start to collaborate a little bit more. The last detail I'll mention before we get started is that there is an opportunity to earn a TE Academy POAP. So we offer these for all of our workshops and research programs, setting up successful participation criteria. And in this case, the criteria is submitting one of the 3 GitHub challenge submissions, which you will learn more about from Danilo in his presentations. But these are fun to collect, also might mean something. And you have, help us identify TE alumni, which is a great crew of people, a lot of really smart people who've made their way through the Token Engineering Academy. And yeah, fun to be a part of. And there's just an example of a few from our past research programs. Last thing, I will obviously have to make a plug for some of the other programs we have running at the TE Academy. First off is the DAO Reward System Research Group. Applications are actually going to close this weekend, so it's your last chance. I'll send the link in a second. And then finally, if you do happen to be new to token engineering, we have an introduction to token engineering session coming up next week. So I'll send both of those links in the chat, and it would be great if you could register. So then that's all I have from the TE Academy side. And now I'll hand it over to Guillaume. Yeah, gosh, I screwed it up again. Guillaume, there we go. Yeah, to say hello from Rai and start with the intro. All yours.
Yep. Okay, everyone hear me well and see my screen?
Yep, all set.
Okay, cool. So yeah, so this presentation will introduce Rai, what it is, like why is it interesting, and also like introduce the controller, like which is the part on which BlockScience worked with, and the topic of this workshop. All right, so I will start by briefly mentioning control theory and what it is. So I assume that most of you heard that word before. Control theory, it's a field of engineering that predates crypto, right? And at a very high level is the science of maintaining stability, or more accurately, algorithmic control of dynamical system. So we see control theory applied in many fields, in industrial system, or for example, cruise control of cars, heating system, power supply, everywhere. It's all around us. And yeah, it's basically about controlling a system. I mean, drive the system into a desired output. The most famous primitive from control theory is the PID controller. So PID means proportional integral derivative. And This is the most basic controllers that we are using for RAI to set an interest rate. But yeah, PID controllers are applied to all sorts of problems outside of cryptocurrencies. I mean, they are mostly applied to like mechanical system, like electric engine and electric motor and this kind of things. First, before we jump onto RAI, I want to point out something about that control theory has been applied to the field of economics before, and there is this paper that shows that some of the monetary policy, central bank monetary policy rules can be expressed as PID control. So like in this example, we are, the author is presenting the Taylor rule as a PID formula. And the Taylor rule is like this famous rule, monetary policy rule that predicts the interest rates based on something like the GDP and the current inflation in the economy. And this has been extended to many central bank monetary policy rules that can be expressed as form of PID or PI control. Okay, so let's move on to RAI. What is RAI? And RAI, as its core, is a fork of MakerDAO's MCD. So like what most of you likely know as DAI, with one very important key difference is that it's not pegged to the US dollar. It is free floating. And yeah, therefore RAI is not worth $1 US. At its core, there is an algorithmic interest rate set by this PID controller, and it is Ether-only collateral. How does that work? So RAI trades on the secondary market, such as Uniswap or centralized exchanges and so on, and therefore as a market price. But RAI also has something called a redemption price. And the redemption price is the RAI target price, or like, as I like to call it, to simplify things, the moving peg. So the redemption price is the peg of RAI, or the target, but that changes over time. So how is the redemption price determined? So first, we will measure the difference between the current RAI market price and the RAI redemption price. From that will be the input to the PID controller, and the PID controller will then determine a redemption rate. So for example, in this case, RAI trades above the redemption price, as we can see by this red arrow here. And therefore, the PID controller is outputting a negative redemption rate. And the redemption rate is what will change the redemption price, is the rate of change of the redemption price. So if the PID outputs a negative redemption rate of minus 11.15%, this means that the redemption price will go down 11.15% over a year if it stays like that. And yeah, so minus 11% means the redemption price is going down in that specific example. And this is supposed to affect the price of RAI. And the loop goes on and on and on for forever.
Is the redemption price the price at which RAI can be redeemed from the system?
Yes, correct.
Okay,
I will get to it.
Okay, got it.
So let's redefine again the terms. So the redemption price, aka the moving peg, is the internal value of RAI in the system. So as you already brought it up, is the price that will be used to mint and repay RAI debt. At equilibrium, the redemption price should be equal to the market price. And the last comment on the redemption price, it starts at an arbitrary value. In the case of RAI, we started with the redemption price of I, so 314 something. And then we iterate over the loop I showed you before, and it might change over time. The redemption rate now is simply the rate of change of the redemption price. We can measure it as an APR, for example, like plus or minus 5%. Last term I want to define is the redemption rate feedback mechanism, which is the system where with the PID controller that look at the price on the market, sets the rate. Okay, so what is this redemption rate doing? Like, what is its effect on the RAI market? Let's look at it from two perspectives. First, from the perspective of the RAI holder, and then from the CDP owner. So from the RAI holder, if the peg goes down, meaning that the redemption price is negative, as a RAI holder, I'm incentivized to sell my RAI, because if I hold on to them and that the redemption rate is negative, I am losing money. And inversely is the same. If the peg goes up, meaning the redemption rate is positive, RAI is supposed to go up in value, so more people might buy RAI. Then from the perspective of a safe owner, so like safe are these CDPs like in Maker they call them Vault. They used to call them CDPs, and we are calling them safe. So those are like those that borrow RAI against Ether collateral. So for them, it's a bit more complicated and actually quite interesting. So if the redemption price goes down, or like negative redemption rate, that means that for them, the peg of RAI is going down. And for them, it actually means that their collateralization ratio is going up. It means that they have more collateral per unit of debt, means that in theory, they could mint more RAI without taking on additional risk. And this might put like, this expands the RAI supply, which put pressure on the market, which should drive the price of RAI down as a result. And in the opposite situation, it's the opposite. Basically, the ratio goes down, and like their safe is more at risk, so they need to buy a RAI to repay debt that would potentially lead to the price to go up. So it's important to understand this mechanism, because like that's what will have effect on the price of RAI by changing this redemption rate that the PID controller is controlling. Okay, so like those are different like criterion that we need to understand when looking at the price of RAI, but we can skip them for now. Now, quickly, I want to speak about RAI on mainnet. So RAI was deployed in mid-February 2021. It currently has a total value lock of about $280 million worth of Ether, and add in total more than 2,000 user position, so safes. And currently the RAI price fluctuates plus or minus 10% of the redemption price. And the rate is actually below 10% most of the time. And there was 10 million in liquidated collateral since the beginning.
Is redemption rate always positive?
So Good question. No. In my first example at the beginning with the loop, it was actually negative, and the redemption rate can be positive or negative. So when here I'm speaking about redemption price going down, this means that the rate is actually negative, and up, this means the rate is positive.
Okay, thanks.
Okay, so like how does that look on a chart? The purple curve is the price of RAI on the market, and the red one is the redemption price. So we can see that around the time of the deployment, we had a lot of volatility, and the RAI was sometimes trading very far above its redemption price, and as a consequence, the redemption price went down over time. And nowadays it's a lot more stable. And this is the same chart but zoomed in, and RAI trades close to his redemption price most of the time. Yeah, for example, here we see that it's slightly above the red line. The market price is slightly above the redemption price, so that's why we are seeing this red curve slightly going down a bit here. This is the redemption rate. We had very high rates of more than 50% per year in the beginning, and nowadays it's rather small, so less than 10% in absolute value most of the time. Long term, like what do we expect the price of RAI to be? Like where will this mechanic lead us in 1 year, 5 years, or 100 years? So hard to say. We don't know. But the key factor is that will there be any sustainable imbalance between supply and demand? If that's the case, the peg of RAI might move over time. But one thing to keep in mind is that the rate, like this RAI price target, will always move slowly in a fairly predictable manner, which is the whole point of a stablecoin, right? You want it to be stable. So it might drift over time, but on a longer time scale, but stable around that price. So why are we doing all that, and why is it useful? So the key in this kind of system is to match supply and demand. So the supply is like the RAI minters, the people that create RAI by locking in Ether and creating new RAI. And the demand is a RAI holder, people that want RAI for various reasons. And there is a paradigm with this kind of system, is that the supply often depend on the appetite for leverage into the market, right? Because the people that mint RAI locked in Ether take a loan against it, and they lever up against Ether. And the RAI holder, they want a stable coin because they want stability, right? And these two phenomena, I would say, are fairly independent from one another, or maybe even inversely correlated, right? When you're in a bull market, you want to lever up, and you don't want stable coins, but in a bear market, you might want stable coins and not lever up. So this is the problem that this redemption rate solves, is that it allows to balance market forces. And so like if you are a trader, like you maybe heard of that in the context of futures or perpetual swaps contract, to the funding rate, that long pay short or short pay long. This is the same. So like this redemption rate can be seen as a funding rate that incentivizes shorting or longing the underlying assets to stay at the index, stay at the peg. How did makers solve that problem? So I'm running short on time, so I will go very quickly. But Maker used to be Ether only, and like they were pegged to $1, and it was not really sustainable for them. DAI was going above the peg due to high demand, and like the way they solved that is by adding USDC collateral. And like if we look at the history of Maker of starting when did they add USDC collateral, it's always when like the market often correlates when the market went burst and that there was not enough DAI supply onto the market, that they had to compensate this lack of DAI supply by onboarding USDC collateral, which can be seen as a failure or a bad thing because USDC is a centralized custodial asset, which kind of conflicts with the original mission of MakerDAO. So yeah, you could ask now, isn't $1 a better user experience? Maybe it is, but it's hard to do without introducing custodial risk, because like if you want to keep it strictly $1, the easiest is to actually put $1 behind it, and things like USDC or would make it much more easier. But since we only want Ether collateral to keep such system as decentralized as possible, we introduce a flexible peg that allows us to balance market forces and our system to be slowly backed by ETH. All right, that's it for my side. Yeah, thank you for listening, and I'll stick around for question and in the Discord.
Awesome. Thank you. And then now we can jump on to Danilo. Should be able to share screen.
Yeah, so I'm going to share my screen here.
Cool.
Okay.
Yes, all set.
Yeah, so I'm going to talk a bit about the RAI digital twin, which is really an effort that BlockScience has made to, let's say, to be able to monitor, let's say, what's the status of RAI, and let's say not only let's say one of the key points is really about, let's say, what can we expect from the future based on behavioral models, but at the same time in a way that, let's say, allows, for example, to include any knowledge about the system fundamentals, knowledge about, for example, how the redemption price works, how the redemption rate works. So this is going to be, let's say, the general topic of those workshops. And I will share those outline this slide afterwards. But for this workshop, I'm going to talk a bit, for example, how the digital twin works, what are, let's say, the critical pieces of the digital twin, and I'm also going to go quickly through how to set up and execute the RAI digital twin, which is open source. And we are also going to have those two workshops, which will be really about, let's say, understanding what was implemented on the digital twin side, and also how you could modify. So, I mean, you could test different counterfactual scenarios and so on. And one thing is that we are introducing, as Peter has said, is that we are going to have some challenges. Each workshop are going to have some. It's a great experience to get a hands-on experience and feedback. I'm going to explain shortly how it works. And there is no strict rule on how to submit. So they can be markdown files, they can be Jupyter notebooks. If you want to fork the repo, you can, for example, just write a markdown file and put a link. It's really an opportunity for getting, let's say, that experience and feedback. Just some quick words about the challenge. We do have this repo here, the RAI Digital Twin workshops. Probably will be built afterwards, but there is going to have a folder for each workshop. And in order to submit it, you need to fork that repository and do a pull request. And all of them are going to be accepted if they are not spam. And also, I'm going to provide some feedback in form of a MD file. So yeah, it's pretty flex on that side. And yeah, let's talk a thing about the RAI Digital Twin. By the way, a quick question, guys. I'm sharing my desktop. Are you guys seeing the Zoom interface here or not?
Nope.
Okay, just to make sure.
I don't think so. Yeah.
So yeah. So as I said before, the digital twin is really, let's say, to be able to have, let's say, a representation of the high system, a way that we can do predictions about that. But I think that one useful thing about going too deep into that is really to disambiguate what is a digital twin. So the hand definition is really a virtual representation of the real-world counterpart. So most of the time, is digital twins, they are really about cadCAD models. And one thing that, let's say, has been emerging that I think it's useful to take notice is that as token economies become more mature, we start to shift, let's say, the representation from, let's say, being used for, let's say, taking this design choices towards more, let's say, health monitoring, towards predictions, and so on. So you need representations to do both of them. But the thing is that onto this, let's say, we can also think that, let's say, there are two types of digital twins. There is the design ones and there is the operational ones. So just to give a summary is, design digital twins are really about cadCAD models where the search space for mechanisms are very open. So you need a lot of flexibility on the design. And I think that most of the open source cadCAD models, they are really design digital twins. But on the case of Reflexer, it's an interesting project because we have examples for both. And to be clear, the focus of the workshop is going to be on the operational digital twin. The idea of the operational digital twin is that we are really talking about a data science workflow, in the sense that, let's say, we need to collect live data. We need to validate, let's say, if we have, for example, a model, we need to validate that model against past data. And we need to know, for example, how well of a job that model is doing of representing reality. And we want to use that model to essentially do predictions. And as I said, I think it is one emerging trend. I think that more and more projects, they are going to have operational digital twins. And I would even risk to say that the high digital twin is the first open source example that we have of that. So it's really a innovative thing. So just to explain a bit, let's say, what is the goal of an operational digital twin? The best analogy that I could give is, on my screen, you can see some pictures from the IPCC report on climate change. And the thing is that, let's say, doing that kind of prediction requires some things. First, you need to do historical validation about, let's say, your physical models. You need to collect data from all kinds of sources and so on. So if we see here the left figure, we can see a time series of the temperature change. So you can see that there is a black line here called historical. And you can see that there is a band here that, I mean, it's sort of a performance metric about how well the model behaves in regard to past. And if we are able to trust enough our model, then we can do predictions over several scenarios. So there is the headline here, which is one scenario. Could even say that it's a, let's say, it's a behavioral, let's say it's a case of a behavioral model. The blue lines, they are other scenarios. And of course, the digital twin can be as granular as it would like. So we have the global temperature change here as a metric, but we could also, let's say, view on other variables too. So this is a way of summarizing. We are on operational digital twin. We are really wanting to measure the health of the system and know the future trajectory on their different assumptions. And the way that we go forward is really by going several steps, one per time. So those are the critical steps. In order to get on those shaded predictions, first we need to collect the data. So there is a retrieval step. We need to backtest the data. We need to do historical validation of the data. So it's really about, we have a pre-representation of the system. So in the case of high, it's really we have the PID controller, which is, let's say, I mean, it's what we believe that describes the actual data. So if we have the cadCAD model for that, we can, let's say, do that historical validation. And if we are able to do that historical validation and, let's say, it behaves good enough, then we can extrapolate into future based on some considerations. And of course, if we have, for example, a lot of different scenarios to test against, then we can start trying to make, let's say, future predictions over all kinds of cases. So those are the basic steps. Those basic steps generate in turn, let's say, what I call the core components of an operational digital twin. So first one is super obvious, a cadCAD model. There is also the steps that I laid out before, data retrieval and preparation, backtesting, and extrapolation. but there is also the step of system identification, because what happens here is that, let's say, in order to extrapolate on prediction, it may be that, let's say, we are interested in, let's say, fitting that against the past data. I'll go in detail on the next workshops. There is a sixth piece, which is really about reports, because after all, we need to be able to, let's say, consume what's being generated from all those steps. Yeah, going a bit over them, as I said, the system representation is really about the cadCAD model. And let's say the function of it is really to encode subject matter expertise. So it's to take, if, like, for example, our knowledge about the physical layer of the system. So in case of height, the physical layer would be, for example, the controller definition. But there is also other things that the cadCAD encodes, which is very critical for the good work of the digital twin, which is like, for example, the behavioral action space. So behavioral action space is really about, I mean, because just the physical layer is not enough. Just having the knowledge that you have a PID controller is not enough, because people are going to have actions in regard to that mechanism. So what could be models of the user interaction? So for example, one possible model is, for example, we suppose that the users are going to arbitrage against the redemption price based on the market price. This is a behavioral mechanism. Or for example, maybe the users have some kind of bias, or they are going to do something random. The thing is that there are several possible behavioral mechanisms, and a lot of times they overlap actually. So the cadCAD model must be able to represent that. And a third kind about the system representation core function is that systems, they do evolve over time, in the sense that, let's say, you have parameters that change over time. For example, the key P parameters of the P controller on high has already changed sometimes. And in order to represent the system accurately, we must be able to keep track of that. So the whole of the system representation is really to keep track of, let's say, of those three distinct spaces. Another core function is really about data retrieval and preparation. It's one thing that, let's say, it's always a bit of work. It's really about having, let's say, ETL, but not on a database sense, but more in a sense that, let's say, most of the time we need to collect data from, let's say, the Ethereum blockchain or whatever blockchain, and we need to transform that into, let's say, to classes, Python objects, and so on. So this is a super critical function in the sense that, let's say, we want the digital twin to be sort of batteries included, in the sense that, let's say, you do not need to think too much about to execute that. And then the following kind of function, which is backtesting, as I said, is really about historical validation. So the idea here is that when we go back to the core function 0, which is system representation, we have, let's say, our knowledge about what we expect the system to be in terms of mechanism, and also we keep track of the events, and there is also the behavioral action space. The idea of core function 2 is we want to test, let's say, the mechanism and the events and see if they behave to the real data. So the behavioral actions, we do not include in here. The behavioral actions, they are used actually for extrapolation. I'm going to go over shortly here. But the idea of core function 2 is really about the mechanism that we are describing, our knowledge about the physical mechanism. Does it correspond to the real data or not? And there is a thing that, let's say, corresponds. Usually it's not, let's say, an exact thing. So most of the time is you are dealing with the error. So let's say, how much wrong is our mechanism that we are represented here? Or let's say, what we think the system is, how much is wrong in regards to the real system? So it's super important to have, for example, loss functions so that you are able to compute the error, and we must be quite flexible about how we define that. Because in the end, let's say, predictions, they are really reliable as much we can represent that. So we need to know, for example, if we are, let's say, if our mechanism can represent 99% of what's happening, or 99.5%, or 95%. So yeah. After this core function of backtesting against the historical data, then we can proceed to system identification. So the thing here is that the behavioral models that I did put on the core function 0, most of the times they do have a lot of free parameters, and they need to be fitted against the real data. There is no, I mean, there is a lot of ways how you do system identification. It's definitely a topic in its own. But the idea is that, let's say, you have several things that are required to extrapolate if you not that, I mean, you know, don't have that question when you have historical data, but when you need to extrapolate to the future, you need to know things like, for example, what are our guesses, for example, for the market price in case of height? Or for example, what are our guesses, for example, about, let's say, what's the percentage of the users that are arbitrageurs? So there are really several parameters that fit into, let's say, generator functions that we need to discover the parameters in here. It's really a huge topic, so I won't delve too much in deep into that. Probably we'll get into that into the last workshop. And the system identification it's very related to the extrapolation core function, because extrapolation is really about, let's say, are we able to, let's say, generate a future trajectory? I mean, we want to know, for example, the residential price 1 week from now. Are we able to do that on a very specific scenario? So we have this core function that, I mean, provided everything that we have before, now we want to, let's say, to have the capacity of having a specific trajectory. And a lot of times, let's say, doing future predictions is really about, let's say, doing extrapolation under several circumstances. Like, for example, what's the extrapolation if you have a shot? What's the extrapolation if you have those kind of users? And by aggregating over several extrapolations, we can have actual predictions. And lastly, this is a core function that sometimes gets a bit under the radar, but I mean, we also need to have a good user experience in the sense that, I mean, we want it to be easy to run. We want the output to be very accessible to input. We also want to, let's say, to make it easy to modify. So, I mean, if you have, for example, a different behavioral model or a different assumption of what could happen in the future, or it must be easy to modify and and also to see what is being generated. And on the high digital twin, you guys are going to see that we have, let's say, standardized reports in the sense that we do have notebook templates. They consume on the digital twin output, and based on that, they are going to generate interactive HTML reports. And probably we are going to see a bit of that on the next workshop. So yeah, those are out ingredients on, let's say, on a more conceptual level. And given out ingredients, we can have our definition of, let's say, of what's the high digital twin. So as I said, the high digital twin is an operational digital twin, and it goes through all those steps that I just told you so. So yeah, we have retrieval, backtesting, certification, extrapolation, reports. We have all of that. And also we do have some behavioral models, so we can, let's say, do extrapolation on an array of scenarios. And I'm going to do a demonstration afterwards. And it's really batteries included, as we are going to see as I set up. So you can, for example, import the modules. The data generated is in a way that you can consume on notebooks, generate also interactive HTML reports. And yeah, as I said, we also have this cadCAD representation. It implements the high PID controller. And yeah, we are going to be able to see, let's say, what we can expect for the future if some assumptions are held. And one way of wrapping everything together is really this diagram that I'm showing right now. I mean, this is a representation of what I usually call the execution cycle. The idea is that the context where we have built the digital twin was really on a context that we would be able to, let's say, to execute the same thing, for example, each day. So each day we would have an interactive report about what's the situation of high, what we expect for the next hours or the next day. And by the way, this is in part, let's say, if you take the operational name, when we call the operational digital twin, it really, let's say, it's based on that, because I mean, the entire idea of that is really to, let's say, have something that, let's say, we connote the status of the system, and if we need to steer, let's say, some decision, I mean, if we need to steer the system or whatever, we would have, let's say, an early warning signal. The idea here is that, let's say, we have all those components here, like preparation, backtesting, system identification, extrapolation. We also have this box here of visualization, diagnostics, and reports. The way that is implemented the high digital twin is really that, let's say, you have a, I mean, you have some code that, let's say, allows you to execute that. And when you execute, I mean, you have the preparation steps that consumes all the data, you retrieve the set of assumptions. Based on that, you have some information. You feed that into backtest, which calculates, let's say, how much error we are having. Based on that, we provide, let's say, information to extrapolation, and with the extrapolation, so on. And one thing that I did put on this diagram, and I think this is an important thing to, let's say, to know how much the high digital twin is cadCAD and not cadCAD, is really the colors here. So the blue boxes, right now, they are implemented in cadCAD. So without cadCAD, you are not going to be able to do it. The green boxes on the high digital twin, it's not part of cadCAD, but they could do. So if you guys, for example, are going to implement a digital twin, operational digital twin, it's really, let's say, the developer option if they want to put the green box on the cadCAD or not. So what I mean is that, let's say, cadCAD could be the entire backtesting through extrapolation, or it could be just a part of that. And the other thing is they are really outside cadCAD in the sense that, let's say, they are really, let's say, a software toolkit by itself. So yeah. And just to have a snapshot of, let's say, of what we can expect from the actual output. So I did run that a month ago. And let's say this is an example figure from the interactive report. We can walk through the HTML report afterwards. But the idea is that, let's say, you have this blue one headline. The blue one is the historical data, it's the data that we got from the blockchain. And the head one is what our model think it should be. For, let's say, for yeah, you take, for example, the difference on this test. I'll dig into more details on the next workshop, but the idea is that the head one represents, let's say, what the cadCAD thinks it should be. And notice, by the way, that the numbers here, they are very small. So even though, let's say, sometimes you see oscillations, we must always take into account the scale of things, because I mean, if the range of numbers are very small, sometimes we see a jump, and we think that it's a super high error, but it's not. And actually, the error here is less than 0.1%, so it's pretty good. But yeah, the head one is what the model think it should be on the past. And based on that, we do extrapolation here on the black line here. So after this point, we do not have historical point data, so we need to use behavioral models. And we can have several, let's say, different behavioral models that we can include. So for example, the green one is, I mean, what happens if the market price simply keeps the same thing forever? While, for example, the orange one is what happens if we introduce, for example, an arbitrager. There are also other two scenarios here, but I did hide them in order to, let's say, not having too much of a polluted graph. So yeah, that's about the high digital twin in a more conceptual level. One thing that I would like to do now is really to show you guys how to set up, how to be able to use the digital twin right now. It's going to be sort of hands-on, so I'm going to share my screen and go the entire process. And yeah, just let me check here. So yeah, after this, after going to the hands-on about how use the high digital twin, I'm going to open the floor for questions. And yeah, I'll talk about the challenge until we open up for questions. So all right. So in order to how to use it, let me, okay. So I'm going to really do a step-by-step, but I mean, there is the link, this link here, github.com, Reflexer Labs, Reflexer Digital Twin. You guys can go in there. So yeah, in order to use it, there are already some instructions here on the README. But beyond the README, I'm also going to show you guys some tricks so that, I mean, you guys modify anything and so on, you can have a good experience. So in order to clone is really go to that repo, go to code, and I mean, select whatever option suits best. I'm going to use GitHub SIL, but it's really, let's say, your criteria. And if we go here below, there are some basic instructions about, let's say, the requirements. So first thing is that you need Python 3.9. If you have Python 3.8, it will not work. So it's worth checking here the Python version beforehand. And I'm going to clone the repo here because sometimes it takes a bit. So while I clone the repo, I can talk a bit about those things. So let me paste here. Yeah, so I'm cloning here on my terminal, and yeah, so about the usage structures, as I said, we need Python 3.9, and we need to install out the requirements. So let's say in order to check if you have the correct Python version, there is this command here. And for example, I could pass here. And yeah, so make sure that it's 9, because if not, I mean, you may need to update Anaconda. I think there is an Anaconda version that already have 3.9, but it's good to double check. And yeah, sometimes it usually takes about 6 seconds to clone that. And after we do that, we are going to need to create a virtual environment. This is not strictly needed, but I highly recommend, because I mean, it avoids a lot, for example, dependency health. And after we set up and pass those comments, we can, for example, test the execution of the digital twin. And there are really some ways of doing that. In the sense that, let's say, we can, for example, do a restricted run. We can try to simply run it. The high digital twin, one cool thing about that is that we do have a lot of unity tests. So it's another way of, let's say, testing. If you modify or anything, yeah, it's a good thing. And while my clone is not finished, I'm also going to talk a bit about the folder structure of the repo. So first thing is that the high digital twin is structured as a module. So it's a Python module if you go here. So, I mean, I won't delve too deep into that, but in practical terms, you can, for example, pass this -m in order to execute the digital twin. And it's possible for you, for example, to import the high digital twin directly and so on. So just to show an example of that, let me see if there is a head one here.
Danilo, a quick question from the chat. This is also possible to run on Windows, correct?
Yeah, it's possible.
Okay.
I'm not exactly sure of what are the specific instructions on Windows, but the only hard prerequisite is Python. So, but yeah, you may run into some trouble. So, I mean, if you have any trouble, feel free to go on the Discord channel, ask. I'm almost sure that someone is going to be able to help. But I didn't test on Windows, so it's a disclaimer. Yeah, let me see if the clone here is done. Ah, okay, the clone is done. So yeah, some ways about how you could consume it. So yeah, first I need to set up my virtual environment. So after the clone is done, you create a new environment here through Python-mvm, and then you activate your virtual environment, and you can see that it worked by seeing here at the beginning, and then you start the requirements. And I forgot to change the there. So by the way, I just noticed that there is a bug here. I should have put a CD on the repo, but yeah. And then install the requirements also take perhaps 60 to 90 seconds. In my case, it's going to be a bit quicker because it's already installed. And yeah. Yeah, while you continue to talk a bit here while the requirements are not styled. So about the folder structure, as I said, there is the digital twin itself, it's contained on the high digital twin. But also we have things like, for example, the reports folder. And every time that you run the digital twin through the entire execution cycle, you are going to generate those HTML reports. And also we have, let's say, the data folder. So this data folder, you have things like, for example, how you change the, let's say, if you change, for example, the parameters of the controller of the past or of the future. There is a file here called control parameters that you could do that. If you go to the runs folder, you have lots and lots of data, but we are going to go over that on the next workshop with more detail, just to have some spoiler. And now my requirements here are installed. So some ways of, let's say, making sure that everything's working. So one option is to simply run the high digital twin. So I could, for example, simply copy and paste that. And this command here, it's going to do a restricted run of the digital twin. So just to explain what this means, if I open here, for example, another terminal and go to the folder here, what happens is that the digital twin does have a command line interface. So if you have, for example, Python -m reflexer, actually, let me remember here. Okay, if you pass Python -m high digital twin and you pass, for example, --help, it's going to provide you with some options. So for example, you could select, for example, how much days you are going to download, how much time you are also going to do extrapolation. And also, for example, there is this option -l that instead of pulling the latest data from high, you simply would use whatever you got locally. This is super useful for debugging mostly because sometimes downloaded data can be slow and it can take some time. So it's almost finishing. And by the way, I'm going to explain the entire execution cycle on the next workshop. There is a lot of information here, but I don't really want, can be quickly a time creep. And yeah, as you can see, it's done. And the output of that is not only the data files, but also the interactive HTML report. If you guys, for example, open, let's say, the folder where I cloned here the repo, and you go, for example, at reports, you are going to see that, let's say, this report here was just generated. And yeah, I'll save the spoilers for now. It's really a topic for the next workshop. And yeah, before finishing this hands-on about how to use, just some things. First one is that if you want to go through the entire execution cycle, so that you put the latest data, you do 2 weeks of extrapolation, you collect, I think, 2 weeks of past data. What you need to do is really to just pass that into command line, Python -m high digital twin. It's going to do everything for you. And the reason of why it's just a command is really because the context of that is really that we wanted to be able to, let's say, to have a cron job where we could run that daily, for example. And yeah, and I want to show quickly, because I think this is important. This can be helpful, is that, as I said, the high digital twin has unit testing and so on. And this is a super helpful way of, let's say, make sure that everything's working. So for example, I don't know if you guys have ever used PyTest, but for example, if you take this command here and you go to the Reflexer digital twin folder, you can pass this command here and it's going to test. And yeah, everything passed. The idea is that, let's say, we have tests about if the control implementation is right, about if user events is right, if back testing is work, if the data retrieval is work, if, well, there is a lot of tests there. And another way also that we could, let's say, perform those tests, and it's not a thing that much people are very aware, but for example, if you use a VS Code, you already have support for those tests here, in the sense that, let's say, there is this testing tab here where, let's say, you would search out the tests. And for example, if some of them do not work, you could, let's say, know specifically what test. And you could also use this run debug. There is an option of running the module that, let's say, if you have a error while modify the code and so on, or also you could also those breakpoints here. You could, for example, press run debug, and it's going to be very practical. Let's say if you need, for example, to see the inner workings of the module. So I put a breakdown here at the execution cycle. We are going to do in more details on the next workshop, but it's just to give the spoiler that, let's say, you can, let's say, see what are the variables that are being used and so on. And yeah, those are some tips about how to use it. So it's really about clone the repo, follow the instructions, try to do a restricted run, try to run the tests, and then yeah, I would even risk to say that from this point, all we are going to do is really to go to the code base and, let's say, see here things how it works. Also give some examples of, let's say, how you could modify, and yeah, that's it for the hands-off. So let me see the chat here. Okay. So just to finish here my, let's say, the main body of the content, I want to share with guys some challenges for this first workshop. There are 3 proposed ones, but of course, if you guys have any relevant questions, I mean, you can create your own challenge. But on a conceptual level, one challenge is the following. Based on all this description about, let's say, this execution cycle, about, let's say, preparing, backtesting, identification, prediction, output. What are the advantages and disadvantages that you guys see about that? Or, for example, for the problem that you are trying to solve, do you think that it could be made differently? So, I mean, it's really a challenge about, let's say, thinking about, let's say, about this whole definition of operational digital twin, and let's say, does it work, does it not work, and what context could be applied? It's an open-ended question, but I mean, I would be happy to, let's say, give you any answers to that. Other two challenges here, they are hands-on in the sense that first one is, are you able to replicate the steps that I just did? Are you able to execute that on your own machine? And if you see the output of it, is it going to match what we've seen on the slides? And I mean, the supervision for a challenge could be something as simple as, let's say, as a Markdown file or Jupyter Notebook. Maybe it could be a screenshot. So feel free to do in whatever way you guys think that, let's say, answers the challenge. And another challenge that it's quite interesting is, as I said before, the HydraDX will accept some arguments. And what happens if you tweak things, like, for example, change how much extrapolation time steps we are going to have, or how much past days we are going to download, and what we are getting out from it. So yeah, try it for yourselves and tell me what you got. And to be fair, I don't know exactly what to expect. So it would be cool to see if anyone tries that. And also, I mean, if you guys think that there is an interesting challenge that I didn't put here, I mean, you are super free to, let's say, create your own challenge, and I would be super, let's say, glad to review. But of course, if you do that, before answering, please, let's say what's the challenge. So, I mean, so there is a double challenge there. There is a challenge of writing a challenge, and then the challenge of answering your own challenge. And yeah, that's it. I would like to, I mean, we did pass a bit of time, but I'm pretty flexible on time. So yeah, if you guys have any questions or want to discuss anything, yeah, this is the time.
Quickly, Danilo, when is the deadline to submit the results for the challenge for the first?
So it could be until the next workshop, maybe one day before the next workshop.
Okay. Cool. And I think I noticed there's still some confusion about the overall concept for RAI. And I guess that's pretty normal if you guys are new to RAI. Maybe Guillaume, can you share some more resources to dig into that if there are questions on the redemption rate and such?
Yeah, RAI sometimes it takes a bit to get used, but there are a lot of references. The RAI people did a lot of great material. I can dig some links and put on the one stop, and I'll ping the Discord channel when this is done.
Yep. And we'll also upload the slides from today too. So if there's anything from there you'd like to look back on.
Yeah. So I'm seeing here some questions at the chat. So for example, Jose Anthony has asked, but a CAD simulation replicating the system is a digital twin. Is there a cadCAD module for digital twin? So yeah, so this is kind of a tricky question because I mean, going back to the, let's say, what's the home definition of a digital twin? It's really a virtual representation. So in a certain sense, let's say, what I mean, it's a bit tricky because when we talk about representation, there are some ways of how you could understand. So for example, one thing is to represent, let's say, the mechanistic layer, the physical layer. Let's say we want to have, let's say, a representation of the controller. Another thing is to, let's say, have a representation about, for example, not only I want to represent the physical layer, but I also want to represent the behavior of people that interact with that. So that's why, for example, we do use this idea that, let's say, there is the design digital twins or there is the operational digital twins, because on the operational side of things, what we are really trying to represent is, let's say, what's going to be, let's say, the day-to-day reality of that system. So we want to represent, let's say, the physical layer, but we want to represent the behavioral. We want to also represent, let's say, what's the impact. So yeah, I'll say of that because in the end, the definition of digital twin can be sometimes subtle. But we found out that let's say, having this division of, let's say, oh, we are representing for design, we are representing for taking operational decisions, that can be helpful. And about having a cadCAD model for the digital twin, there are 3 repos about RAI right now. 2 of them are related to the design digital twin, so you could say that they represent more of the physical layer. And there's this one that I'm showing that, I mean, it really tries to take this more operational setting. And there's also another question. So there cannot be a generic module or cadCAD template for a digital twin. That's a good question, actually. I mean, it could be, and I mean, it's a bit tricky because there is also the fact that, let's say, just to be clear, I'm supposing here that we are asking about the operational digital twin. In that sense, yeah, it's possible to maybe have a generic module, but there is also the thing that, let's say, this pattern is relatively new. So one thing is that, let's say, as you create modules, first you want to have a, let's say, a systematization of what you are doing. You want it to let's say, because the basic role of, let's say, creating modules and so on is, let's say, first to implement, first to represent things that you are trying to solve. And after, let's say, one thing has been implemented several times, you start to systematize that into modules. But yeah, for now, I would say that right now, each digital twin needs to be specific. Yeah, that's correct. It may be that, let's say, once we have enough examples, maybe we get the overall, I mean, we create generic patterns and we can build some of that. And there was a question here about market behavior as component of the model. Yeah, we are going to have some examples. This is going to be actually the focus of the 3rd workshop. And to be fair, my main goal with the workshop is mostly about, let's say, making you guys feel at ease, let's say, with introducing new kinds of market behavior. We do have some examples of, I mean, we do have a behavior that depends on historical actions. We do also have another behavioral model that makes use of arbitrage. I'm going to explain things shortly, but my focus is not exactly saying that, let's say, we have the best market behavior. My focus is really about, let's say, make you guys able to, let's say, to experiment with new market behaviors if we do introduce on the future extrapolation. But yeah, let me see if there's more questions on the chat.
Xue, did you have another one? I might have lost it further up, but if you'd like to chime in with another question, feel free.
Yeah, I just saw that there was another question here about Lee about to connect the 2 parts of the lecture today. Is digital twin like a PID that helps for the stabilization of redemption rate? So the answer is no. Let's say the PID is the real system. The PID is on the smart contract. The digital twin is a local software that you run on your computer or in a cloud environment that allows you to understand a bit better the real world system, supposing that our representation is accurate of the real thing. So, I mean, the digital twin is, let's say, it's like, I mean, you want to modify the real system, but you need a safe environment in the sense that, let's say, you want to try out the different kinds of mechanisms, out the different behavioral models. And it's a way of, let's say, creating, let's say, counterfactors. It's a way of, let's say, creating alternate histories where, let's say, you have this safe environment and, I mean, you try things before deploying. And
I think that might have been it, except for this one about the repos. So is there a difference between the repo you were showing and the BlockScience Reflexer repo?
On the Reflexer one, there are actually 2 repos. There is one which is the GAB simulations, and there is the RAI Reflexer digital twin. So the difference is that the GAB simulations, they were used on design work essentially, because the context is that, let's say, there were parameters to be set up. There were several discussions about, let's say. So what I mean is that the GAB simulations, they are really about, let's say, gaining understanding about how the PID controller would play out before, let's say, actually deploying. So what happens is that on that case, the design search space is much higher. because I mean, there are a lot of things that you can experiment. Well, the one that I did, we shared today, the Reflexer Digital Twin, I mean, we already had a more stable definition of how the controller would play out, or how would be the general dynamics play out. And we are really interested more in, let's say, forecasting of the different scenarios, rather than try to search the design space.
Cool. Awesome. And that was all that I had seen come through. If anybody has one last question to bring up, feel free to ask it.
Yeah, maybe Danilo, one quick question, like in the workflow, I see you do like system identification and then extrapolation. But how are you using this digital twin to like govern the system? For example, if you extrapolate it and see, okay, it's next week or next 2 weeks, things are going to be really bad. Are we going to do anything like using the results from the digital twin to change something of the system? For example, KP parameter or any other parameter of the controller. Is that how you're using? Yeah.
So I think there are two questions in there. One is about how it could be used in a governance setting, and the second is how the high digital twin is being used right now. About the first question, I mean, there are several ways of how you could use for governance. So for example, one example is suppose that there is a community proposal that you change a parameter or add a new mechanism. This step prediction step could be used for, let's say, testing so those different options as a part of an argument. There also could be other things. So suppose that the extrapolation time is long enough and we see that, I mean, we do have something weird happening over the next 3 or 4 weeks. Of course, it's always important to, I mean, because the behavioral models that drive the future, they are not perfect. I mean, you are always going to have limitations, and the best that you can do is really to, let's say, having explicit assumptions and test those explicit assumptions, not only, let's say, different explicit assumptions, but also, let's say, combine them. What I mean is that it's also very important to, let's say, to interpret, let's say, any warning signal in the sense, in the light of the models, just like in economics. When economics is used, for example, macroeconomic models to understand something, sometimes you use supply and demand. So what the digital twin really, let's say, provides is a framework where you could, let's say, express, let's say, this subject matter expertise of what could happen, and let's say have a standard framework to compare them, and let's say have an interpretation. About the second question, which is how the high digital twin is being used right now. So the context is that we did develop this digital twin over the past months. It was mostly on the beginning of the year, and it was handed off. So I'm not quite sure how it's being operated because, I mean, I'm not, let's say, I'm not doing operations of the digital twin. I did the development. So, I mean, I'm not able to answer that question.
Thank you.
All right. Any last question or comment? We can also save them for Discord too, since everybody's found the channel now. Great. Cool. Then yeah, if you haven't sent your introduction to the Discord channel, please do. Then we can all meet and say hi and start working out of there. If you have any questions on the challenge, feel free to reach out. Otherwise, that wraps it up for this week. And we'll see you all on Thursday next week, same time, same place. Cool. Thanks everyone for joining.
Yeah, thanks everyone.
And thanks presenters.
Thank you.
Yeah, thanks everyone.
Bye.